Thank you, everybody, for joining the NVIDIA Omniverse live stream. We have very special guests today. Not only my great colleague Richard and Amelia, who's helping behind the scenes, but we're joined by Steve from McNeil and also Scott and also Vishu, who is from a great architecture agency. We're going to learn more about him and his work in a minute. The focus of today is leveraging Rhino 3D and OpenUSD and how to develop custom toolkits, which you're going to see beautiful example in just a few minutes. Before we get started with the show, we wanted to kind of obviously let everybody know about GTC, which is coming up in 2 weeks. Hopefully everyone who's watching has already registered. A couple of important notes I want to call out that it is free for virtual, and you just go to nvidia.com/GTC. We'll post a link in the chat also, which will enable you to get a discount, a 25% discount actually, if you're coming on site. And I can't recommend coming on site enough because there's nothing beating being able to network with not only NVIDIA developers and also business partners and other members of the community, but also engaging with the live sessions. We have an OpenUSD and day and training sessions. I'll show those that information in just a second. But there's really nothing beats going there. If you are going, we have a great meeting app that helps you leverage an application to set up meetings with not only other NVIDIAns, but other people who are attending. You can look for people by topic. You can browse through people who are attending and see who might be a good fit. It's going to be an amazing conference. The other thing you should probably put on your calendar is the keynote, which kicks it off with Jensen. There's a lot of work happening right now. People are going to be blown away by the keynote along with the rest of the announcements at GTC. This is a big one. Not only is this the first one on site or in person in 5 years, but obviously a lot's happened in the past year, especially related to AI. So we're going to have a lot of great information for people who are really looking forward to furthering their development and getting some resources from NVIDIA and our partners. So let me see. So I have some information here we can show off about what's happening during GTC on that Tuesday, March 19th. We have OpenUSD Day. So we talked about this a couple of weeks ago on the live stream with Stephanie. She gave a great overview. But here you go. We've got a full day, including amazing networking events like breakfast and a lunch. You can sit at a table with experts based on topics. But look at all those sessions available on the left. It's going to be a packed day. OpenUSD is basically nothing stopping it at this point. We're seeing a major adoption across all industries and companies really to want to make sure that their workflows can be supported by OpenUSD in larger ecosystems. So really exciting content that's going to be there. And look at some of those partners: Adobe, Autodesk, Jaguar, Cesium, Land Rover, Pixar, Samsung, Siemens. It's going to be a fantastic day. The other thing we have going on is obviously training sessions. We've had a lot of chat about this on the community Discord, but these are training sessions and labs where there's going to be hardware there for you to work with experts on different workflows and showing you how to develop with OpenUSD. A lot of focus, obviously, on industrial digital twins, but we hope that that as many people are coming to the sessions can get a spot at the lab. So make sure you register. The GTC site is being updated pretty regularly with latest information. We'll post a link in the chat also for that brain date meeting application, networking information. But it's really going to be an amazing week. We're going to try to update the community as much as we can virtually through the Discord server. So if you remember the Discord server, awesome. There's a GTC channel there. If you're not a member of the Discord server yet, don't worry about it. Super easy to join. Obviously, it's free. Discord.gg/NVIDIA Omniverse. And you can look at all the different channels by topics, including the GTC channel. We're going to be posting announcements throughout GTC relating to what's being announced at GTC. So it's a great place to keep on top of everything. So I look forward. If you are headed there and you want to meet, look for me on Brain Date. I'm on there. I put my picture up there this morning, so you won't be able to miss me. And I am very excited to talk about the topic of today. As I said earlier, we have a lot of special guests here, Steve and Scott McNeil and Vishu. So why don't we start actually with introductions? Richard, why don't you go first? People know who you are. Yeah, your mic is not working for some reason, but we'll give him a minute to do that. Okay, Steve, you're up next.
Okay, can you hear me?
Yes.
All right. Hi, I'm Steve Baer. I'm a core developer for Rhino and at McNeil. Been there for a long time, typing away.
And you guys, we were talking about this earlier, but you guys released a major update, obviously, which is one of the core focuses of this live stream. We had a live stream a couple weeks ago with a couple of users. So congratulations on that.
Thank you.
Yeah, I think you mentioned you guys have a release about every 3 years or so, major release.
We try, but yeah, the last two have been on a 3-year cycle.
Cool.
But we released Rhino 8. I think on Halloween, Scott, right? On October 31st, if I'm correct. And so now we're kind of deep in the initial service release, bug fixes, after,
that's awesome.
After a 3-year release.
That's great. Well, congratulations. And
Thank
can't wait to learn more about that and how Vishu has taken full advantage. Scott, why don't you introduce yourself?
So I'm Scott Davidson, been working here forever too. I talk to customers, help, kind of push the AC agenda forward around here, and generally always interested in seeing what's new, and as we're all experimenting with all this stuff now.
I know it changes every day. I'm really happy to have you both here. They're for the community people watching. They were gracious enough to join us just to be part of the chat. So they're gonna be active, engaged panelists, but nothing officially to present. We're going to let that honor stay with Vishu. And Vishu, tell us a little bit about yourself and your background.
Yeah, thanks. Hi, I'm Vishu Bhushan. I'm part of Zaha Hadid Architects, the computation and design research group. I'm an associate there and also lead developer of the computational framework, which we use to power our geometrical things. And then the presentation will showcase how we are using that framework to connect with Rhino, with NVIDIA's Omniverse, NVIDIA CUDA for GPU computing, and also other platforms like Maya and Unreal.
That's amazing. Taking full advantage of a nice stack there. And then we'll circle back to Richard. Hey, Richard. Oh, it's still not working. You had all this time, man. For some reason, your audio is not coming through. You're not muted, but you may need to maybe jump out of StreamYard and come back in. That'll probably fix it. But we'll let Richard introduce himself when he comes back. Richard obviously is our community manager, you can see, but his background is in the AEC industry, so he'll be great to have with us. So so why don't we kick it off by just talking about some of the major updates that happened with Rhino, just really briefly, so people can understand. And also, actually, let's take a step back and let's talk about what Rhino is and who in the world should be using Rhino that's maybe not using it yet. And tell us about some of the major uses that people have for it. And that could go with Steve and Scott or Vishu, any one of you three.
I'm the developer, so I'm gonna let Scott jump on that one.
I can give the general one, but Vishu's probably got a much better approach to this than I do. So Rhino really is about accurate freeform modeling. So it's used for design across many different markets, whether it's jewelry, footwear, large stadiums, just about anywhere where you need kind of really to do shapes that nobody else thought of. In addition to that, we have Grasshopper, which is really a parametric, freeform parametric engine used mainly to when you have a lot of repetitive parts, and you work through there. But Vishu probably has a better approach how it's used in AEC.
And a lot of times too, I think our general goal of what we're really proud of is that you can actually physically make something with Rhino from the design. It's not purely for for an image. I mean, a lot of times, sometimes it is for an image, but many times it's actually for physical production.
That's amazing. Yeah, we had. Go ahead, Vishu.
Yeah, just to pick up on that. Yeah, on the architectural side, it's within the office. It's used at various stages of the project. Some of them use it for early stage competitions, but predominantly within at ZHA, it's used in the later stages in the SD/DD stages where we have to deliver parametric models and optimize geometry and collecting all the various packages. So that's where Rhino is typically used within our setup. And yeah, like as Scott was mentioning, like the Grasshopper and the parametric setup is what is like quite used quite a lot in the later stages of the projects.
Amazing. We're going to put the link in the chat to Rhino so everyone can kind of take a look at their website. Put that right now. And then everyone watching, great to see so many viewers today. Please feel free to add any comments or questions you have in the chat, and we'll try to hit those as we move along. But you're in for a big treat today because Vishu actually gave a sneak peek to the presentation you're all about to see to some of our team members here, and they were blown away. So Vishu, love to hear more about like your company, and then when you're ready to share your screen, feel free, and we'll put up on the screen for everybody to see.
Yeah.
And while you're doing that, Richard, want to give it the third time's the charm? Let me see.
I think you can hear me, right?
Here you are.
Okay, I'm sorry. Unbelievably, my mic needed an update during the show and just shut down. That's technology for you.
Well, we're very happy to have you here. And your background is in AEC, correct?
Yeah. My background is a long-time renderer of all things interior, exterior. Obviously know the group very well, and yeah, just big. I'm a Max guy, but I know Blender is incredibly powerful, and I'm sorry, Rhino is incredibly powerful.
Very cool. Well, thank you. And I see Vishu is sharing his screen. Okay, I think we all see it now. Let me take away. Okay, so yeah, so take it away. Tell us about your deck here.
Yeah, cool. Thanks. Yeah, first of all, thanks for the invite. Happy to be part of the discussion along with the McNeil guys. It's always a pleasure talking with them. A bit about myself. As I said, I'm an associate at Zaha Hadid Architects and part of the computation and design group. And I also teach at the University College of London. But today I'll be focusing mostly on the work I do at Zaha Hadid Architects, which is looking into research in computation and design, and also developing the software stack for exploring those.
Very cool. And I don't know, it's just intentional, but the screen we're seeing now is a presenter screen. So I don't know if there's if you want to switch to the other mode or go to view and slideshow.
How can I change that?
You should be able. You can stop. You could. Yeah, we're seeing the presenter mode. So we're seeing basically the list of slides on the left. And that's the view you wanted to go with. That's fine too.
No, actually, I want to show the full screen, but how do I show presenter?
So maybe,
maybe
you could either go to view at the top and then try to go present, or you can if it's basically picking up a different screen, you could stop presenting and then do it again in StreamYard. Go to present again and pick the different tab.
What are you seeing now? Because now I see myself the presenter view.
Yeah, we are seeing. We're seeing the presenter view. So basically, we're seeing your list of slides on the left, slides 1 through 6. And
maybe let me just stop sharing.
Okay, yeah, that's probably what it is. I know sometimes StreamYard will pick up the wrong screen. Keep the comments coming in on the chat. We're going to try to take as many questions or comments as possible. Let us know if you're attending GTC. Be great to set up any kind of support for folks that are coming. Let me see. I think okay. So now I see your screen is almost here. Let me see.
We're having some technology glitches today, guys.
Here we go. I see it.
So now you see the full screen,
yes.
Right?
There you go.
Yeah.
2007 to present.
Yeah, cool. Yeah, so ZHA CODE, the code is acronym for computation design. It was started in 2007 by Shajai Bhushan, Niels Fischer, and Patrick Schumacher. It was started as a project-independent research group, but with the focus of developing a mandate to develop computational tools for application in delivering projects and also designing of early stages of design. So as you can see, as the group started in 2007, we did like small scale buildings, and as the technology and the computational power grew, we are now kind of showcasing the application of that research in large scale projects. I co-administer the group with currently with Henry Louth, who is also a colleague in the group. Our research kind of sits under these 4 things, like high performance geometry, participatory design, gaming and metaverse, and machine learning and AI. And then we have done wide ranges of projects, as I said previously, like initially starting off with like small scale projects to test out the computational technologies and what is feasible with it and what are the tectonics we can develop with it. And then as the technologies has matured, both in the computational design side, but also on the digital and robotic manufacture side, we are able to showcase its application in wide ranges of projects, including stadiums, master plans, metro stations, offices, etc. On the gaming and the metaverse side also, we have wide scales of projects looking at galleries, looking at full-scale master plans, doing digital platforms for user interfaces, and also working with game industry like PUBG and Fortnite, etc. Typically, like our four things any research goes through is first we create like project independent research, then develop custom toolkits to showcase its applications, and then it's tested on special interest projects or small scale projects, and then once it has been robustly tested, it then gets deployed into large scale projects which the office runs. So all of that is powered by like what we call ZSpace, a spatial technology stack. It's a software agnostic computational framework, which kind of delivers both at the content creation, which is early stages of design, but also at content delivery stages. So we take a look at like a lot of various things in it, like looking at form finding techniques, how to do geometry processing, how we can optimize geometry for 3D printing, digital timber, and also showcasing data and metrics to how it can be assembled on site. So it covers a wide range of things, including game tech and platform design.
Wow, it's pretty robust offering there.
So the framework kind of talks to all of the platforms the office uses. So all the software suites, including Rhino, Maya, Unreal, Omniverse, and NVIDIA, and also the machine learning aspects. We tend to develop it in C++. So we talk to a lot of the Rhino core side, and also through C# we talk to Rhinoceros and Grasshopper. But making use of Rhino core has helped us a lot in kind of extracting Rhino out of its current interface and access it externally. And it also enables us to use that Rhino inside of Omniverse, and Pixar USD also helps us to do that. Yeah, this is just a framework and various modes of interfaces. People developing on the source code and core developer is a smaller team, but then the custom API is where a lot more wider group of people are using that. The spatial technology stack, we borrow extensively from computer-aided geometry design, computational geometry, and specifically from computer graphics. So that's why we look up at companies like McNeil and NVIDIA, all of these companies which are kind of leading companies in these domains. So we borrow a lot from you guys. So that's why it's always fun to be in panels in discussion with you. We also look up at the research domains, look up at what people are doing in various research institutes across the world, like the Block Research Group at ETH Zurich, or the Applied Geometry Group at Vienna, EPFL, MIT, so on and so forth, and try to incorporate research in geometry into our framework. So our design pipelines kind of follow similar procedures like how a movie industry or an animation industry does. So the tools we use are also very much similar, like mesh-based or sub-D in Rhino. And hence we want our tool sets to be aligned to those geometry processing pipelines. And the goal of the framework is to kind of augment designer intelligence to give as much information about performance at an early stage of design. Like the performance can be related to structure, it could be related to how it's going to be fabricated, environmental performance, spatial performance, so on and so forth. The goal for us for the framework is to actually augment BIM, kind of showcase or add additional attributes of manufacture into these building information models, and that's kind of the goal. And OpenUSD is kind of a great example here, because you can capture a lot of attributes which can be plugged into a file, which currently it's not feasible in BIM. So I'll focus the next part of the presentation on things we are doing with NVIDIA Suite and like an OpenUSD, and what are the integrations we are kind of setting up there. So one of the platforms we are looking predominantly is Omniverse, which is kind of a geometry collation platform and collaborative working. It's kind of very useful to first, we had to build up an understanding of how the file structure had to be set up. But once that we crossed that hurdle and set up the server and things, it made a lot of sense that we could kind of bring in geometries from wide ranges of platforms, especially given the software suite we use in the office, like Maya, Rhino, Unreal, even our own platform. So it made sense that all of it, Omniverse was able to speak to all of them and collate the geometry in one place. And this enabled us to kind of visualize all of the geometry in one place, but also kind of do optimizations or variations in platform of choice of the designer, which could be Maya, which could be Rhino, which could be Unreal, which is pretty awesome. At the same time, it can also handle like wide ranges of projects and like a lot of polygons. You can see the range of projects we are kind of exploring, which changes from pavilions and stations to infrastructure projects and sports and stadiums, ranging from 20 million to about easily it handles up to 60 to 80 million polygons, which is kind of pretty useful to actually navigate inside of the environment. And that has been really helpful for project leads. But at the same time, it has a large set of suites of connectors, which has enabled for easy connection with the platform suite we have. But where things are missing, we kind of developed our own custom connectors. So the things you see in magenta are the connectors we have been developing in-house, and the blue are existing connectors which are already available with Omniverse. Again, we started out with typically using it to syncing, like especially showcasing how multiple users can be doing various things. One of them doing modeling in Maya, while someone else is setting up the material and things like that in Omniverse. This is kind of showcasing the live mode. But the more interesting ones are actually on the visualization aspect. So because the geometry is already collated in one place, people can start looking at visualizations at a very early stage in the project, which has made it very useful. And while we still keep updating the geometry, people are already setting up the visualization aspects for each of the projects I'm showcasing here. On the custom connector aspects, as we said, like the current Rhino connector kind of uses the render mesh at the back end, which kind of triangulates the mesh. But for us, it was very important to maintain the topology for downstream production. So hence we had to write our own connector. In this case, that's why the use of Rhino core, which could be called external to Rhino, was very useful, and as well as things like doing the USD mesh, USD API was also very useful. So it was very easy for us to connect to these platforms through our libraries, and that made our life a bit more easier. And this is kind of giving you an idea of kind of code we had to write, right? Because I said we tend to keep our core at C++, and then we write our kind of external interfaces in C# and Grasshopper, which is pretty much similar to how Rhino is set up as well. So our frameworks kind of mimics that. Here showcasing a video of how the connector works. So this is a geometry in Rhino, which is kind of also analyzing for planarity of the geometry. And then this one is kind of pushing out into the Omniverse. And then through our platform, or this can be in anywhere, we are logging into Omniverse, loading that geometry, then running some optimization on top of that. In this case, it's about planarizing the geometry, or it can be any such optimization. So you can see now over a period of over the next 10, 20 seconds, like you can see everything becoming green. That's basically all of the panels are becoming planarized. So in this case, we are using this platform you're seeing is a standalone platform, but it is able to call OpenUSD, it's able to call Rhino, it's able to call Maya, and it's also able to call our own geometry pipelines. And then again, sending it back and connecting back into the Rhino, or this interface can be even in Omniverse or any other platform of use. So which is kind of gives us a lot of flexibility depending on the user. So these are the currently what we are exploring. One is through the ZSpace viewer, which is the C++ side, but using the Rhino core, we are also able to do like a standalone Rhino viewer with additional buttons and things, which is on the top right. And then the custom, the regular Rhino viewer on the bottom left, and then the Omniverse viewer of the same geometry. So this enables us to connect to all of these platforms, use its own benefits in wide ranges of things we want to do. And gives us a lot of flexibility and makes the procedure also much faster, because you can use specific platforms which are good for its best usage. So which is kind of very useful. And that kind of highlights that like we are able to manage like all various scales of projects through various platforms. So once we have the setup right, you can see like each of the projects here is kind of getting geometry from various stages, from competitions and schematic design and DD from various platforms onto a collation and collaborative working through Omniverse, but in connection with Maya and Rhino. In addition to that, it also enables animations and data viz, which is also something we have been exploring, which is pretty cool. It's like the simulation we just did can be saved out as an animation. So these things, we can keep it we do like a lot of animations within the office. So this becomes an easy way. We don't have to set keyframes or things right through using OpenUSD's API. We are able to just save that animation and just run through a time frame. So which is also very useful when we eventually have to create animations. Typical use case for other things is like kind of doing design variants, like how the geometry has changed through various stages of the projects, and then kind of making a comparison. So it's also pretty useful. But the more important one we want to do is like kind of do custom data visualization and by charts, which has again through integration with Plotly, we are able to do that, and this becomes a custom extension within Omniverse where it kind of reads geometry and gives data attached to that. This could be related to the paneling cluster, which will be for manufacture, or whether they are planar or double curvature or single curvature, whether it's if it is manufacturing information like 3D printing, it will also hold information about G code, and so on and so forth. So the goal is for that, like to kind of visualize these kind of information and reports to be generated straight out of Omniverse using the various platforms. In this case, looking at something like planarity analysis, or if you're doing master plans, like what are the parcel sizes, what is the GFA, so on and so forth. All of that could be captured within this data visualization extensions we are currently developing. Another goal would be also it's easy to do these kind of visualizations, which is to kind of augment imagery with data sets. And that's also something we are currently looking at, especially when we are focusing on large urban user-oriented insights. And last part would be on the extensions, which is like building custom extensions. So we have a tech lab at the office, which is like a robot lab, and other digital manufacturing, like 3D printing is also available, and CNC. So the goal here was to kind of create a digital twin of all of the functionalities of the tech lab. In this case, the robot with hot wire cutting, 3D printing, so on and so forth. So we started creating a digital twin of that in Omniverse using our connection with our platform. So we integrated our IK systems into here, and it also generates the G code to move the robot, the physical robot as well. So this here is showcasing an application of robotic hot wire cutting. Like the initial part of the wire cutting aspect was kind of developed with Robert from Omniverse, and also Cobus was also part of it. So it was very useful to kind of get a insight into how to use these things, and the workshop was very useful to start developing our extensions. Again, similar kind of pipelines, again, talking about reading geometries from Rhino, post-processing them using our platform, and then pushing it for the simulation in Omniverse. And once we are happy with the simulation, it also generates the G code, which is sent into creating the actual blocks or running the robots themselves. So the setup also enabled like wide ranges of teaching. So this is showcasing, it was used in a workshop scenario using UME Studio, where users were able to interact with the extension, and it was very easy to make the extension and make it public. So it was also, and make updates. That was pretty useful as well. But it also enabled these kind of other things like AR related things to visualize the geometry in the tech lab next to the physical robot and see if the moments of the digital and the physical are actually similar. So that was also very useful for the students, and this was also exposed in the same workshop, which we did in collaboration with Omniverse. The last part of it would be like with NVIDIA, we've been also looking at the CUDA aspect, which is like GPU computing, and how we can integrate, again, various platforms with the CUDA aspect to accelerate the compute time. One of the applications we did recently was looking at sign distance fields. This was for a 3D printed bridge in Venice, and subsequently a second version in Lyon. In this case, you can see like all of the sign distance fields was computed in parallel. So if this gave us an acceleration of 95 to 100% GPU acceleration, if it took like 2 hours to do 50 blocks in the CPU, the same 50 blocks was done in 2 minutes using the GPU. So it enabled like a lot of iterations of the printing path to be generated and create like a lot of variations, which has like a lot of potential for in the upcoming commercial projects which will use these technologies again. Similarly, kind of looking at solar simulation using, again, doing like 50 million calculations in real time. In this case, looking at solar analysis, you can see while as you're modeling or making changes on the left, the solar analysis is kind of, or radiation is getting updated real time. So this is very useful, especially when you're trying to do certain kinds of convex geometries, which you will see in the next slide, where geometries could have these kind of hotspots because of collection of the rays of the sun. And to avoid these kind of things, these tools become really useful. You're getting almost real-time feedback while you're making the changes to the geometry. And the best part of it is using subdivision modeling. The designer is actually controlling the low polygon geometry, but the simulation is run on a higher division model. So it enables for quick manipulation of the low polygon to kind of go away from the situations of the hotspots, which is again giving us like a lot of accelerations in terms of design, but also it's also kind of pushing the domain of the design into the right space at a very early stage. We don't have to do optimizations at a later stage of the project. So it's in general, that was like an overview of the various things we are kind of doing, and a big shout out to the team who have helped develop the zSpace core stack and the GPU computing aspect, but also doing the Omniverse integration and Omniverse projects. And thank you for listening.
Wow, I have to say, well, go back to that team slide for a second. That is an amazing team. I cannot believe the amount of work you just showed off in that presentation. Let me see. I didn't want to block the screen for presentation, but earlier we saw this from Eric. He just he just couldn't believe what you guys were doing, and the basic leveraging GPU in the way you are. But just like, wow, you really have leveraged Omniverse as a platform to build exactly what you needed for all your different types of workflows and applications. That's pretty amazing to me. And also the breadth of the projects you were showing off. You guys do some really massive, looks like very massive commercial projects. Looks like globally too. I saw things pretty much all over the place. It seems like you have a very like, number one, you jumped on OpenUSD. It looks like very early on. Can you kind of talk about that a little bit? Like, what about OpenUSD kind of convinced you that you needed to kind of start developing for it?
Yeah, so this is also kind of a good example of not only GPU computing, but you can see the information we are trying to store on the right? So we are kind of showcasing like also geometry creation information into a file. And OpenUSD is like a good example for that. Like it enables, so in this particular case, we didn't use OpenUSD. We were using a custom file format, but it's the same kind of logic like OpenUSD. Once we started looking into OpenUSD, it makes a lot of sense to, because we were already thinking along those lines, it made a lot of sense to kind of integrate our thinking with OpenUSD, because we want to capture these kind of geometrical information, which showcases the creation of it, but also includes how it's going to be manufactured. This is only part of the video. I can send you the link of the whole video where you can see this part also getting added to the how the robot G code is also embedded into the same file. So basically, one file will store all of the information from creation to manufacture, which was what like OpenUSD and OpenBIM actually would be looking at. And it's natural that these two worlds come together for us, because we have been looking at the computer graphics industry for a while. And as I said, like our tools are already aligned with them. So again, that was also another reason why it was easy to adopt OpenUSD for us.
It seems like, yeah, because I mean, looking at the number of apps you're using, they're very specific for different usage. And what I love about what you're showing off is that you didn't have to give up what you know and what you loved while you chose those specific apps for your business. OpenUSD allowed you to kind of build your own connectors if there wasn't an existing connector, and just basically just improve your workflow, so you're not seeing things get dropped in between importing and exporting, creating a lot of extra work for people. Was it it seemed you guys are obviously very active on the connector front. Can you share a little bit about the process for actually developing your own custom connectors? Was that it looks like you've been doing very busy in that area.
Yeah, sure. Yeah, so the custom connector part in this case, it was using, again, using like the open source code from NVIDIA, which had a sample connector project. So we kind of developed a class based on that. It's called Z Omni Core here, because we developed a class which connects to Omniverse. And the same way with Rhino, actually. Rhino Core, we have an equivalent of Z Rhino Core, which calls the Rhino Core to launch Rhino in external platforms. So that has been, so talking to both the Omniverse side and also on the Rhino side has been very useful, because now we can talk to both of them from our own platform, but also external. It can also be called externally to the native platforms they are typically used in. So, but it involves a bit more writing of code and kind of developing the external interface, both on the C++ side and the C# side. these middle two steps is additional step you need to take to make these connections. But once you are set it up, it makes a lot of sense. The same thing can be used in Grasshopper, same thing can be used in Python interfaces. So it makes a lot of sense. So the logic and the core algorithms resides in C++. You write it only once, and then you develop interfaces for them on various platforms. So
very smart. That's fantastic. And how many how large is your team overall? The whole team?
The whole team is 20, and all of them are kind of architects with an interest on computation. But yeah, developing the platform is not everyone is involved in that, but most of the team is involved in, because we also have to deliver on projects and on design side as well, because it's a computation and design team. So so there are various interests within the group. Some people more oriented towards developing the compute side, some people more oriented to on the design side.
I mean, it's just incredibly impressive. I'm really blown away here by what what you guys are capable of. Pretty amazing, very inspiring. Feel free, anyone who's watching in the on the stream right now, feel free to post any questions you might have. We got a good question earlier from Ordinary Alan. I'll put it on the screen, and I apologize in advance for Scott. This is going to take away your face a little bit. We'll bring you back in a second. Do you see the industry use of 3D tools like this speeding up? I mean, yeah, that's a great question. Obviously, Rhino is a great example, right, McNeil, and leveraging OpenUSD and supporting it in your app. But what do you guys think?
As far as using OpenUSD with Rhino, is that what you're?
I think so. I think he's asking about ordinarily. Feel free to clarify. But I read the question more of OpenUSD kind of empowering more apps jumping on board.
Sure. I mean, we've found over time, and I think one thing we've been pretty successful with is just supporting every file format under the sun, and it's really about with the highest quality of fidelity too. Right, and so we're trying with OpenUSD to do that. I mean, to write whatever we can into OpenUSD, but have it make sense. Right now, we know that most other applications, what they know how to read would be kind of mesh data. Rhino traditionally is like a NURBS modeler, and NURBS geometry is not something that a lot of other programs know. So we haven't spent a lot of time like putting NURBS data into OpenUSD because we would be the only people that know how to read it back out. I do know that we did add NURBS curves though recently, I believe, to OpenUSD because there was a use case for that. I think over with Adobe Substance, I think they really wanted that for manipulating curves and stuff like that. But
yeah, that's kind of the beauty of it too, right? You can do what works best. You don't have to take in everything. It just it depends on your audience, your community.
Right. And there's parts of it that will be just big projects that I don't know when we'll get to or whatnot with OpenUSD, or things like annotations and stuff like that other programs probably don't care at all about. Yeah. But also we're trying to make it, and I think Vishu also showed, with some Grasshopper slides, we're trying to make it so that with OpenUSD, not only do you get just our standard file exporter, but we're trying to make it so that it's somewhat programmatic too, that you can kind of slide whatever geometry you want to in when writing USD files from Rhino through scripting or through Grasshopper.
Yeah, I think that's where it's quite useful, right? Because you are now able to capture like a lot of data while writing files. So you're able to put custom attributes, which will be very use specific. Not everyone will probably require that. So it makes sense that you should be able to add custom attributes, and which the file format allows for, and Rhino has also been supporting us on doing quite a lot of these things, which is kind of even on the NURB side, we have had some discussions with them previously on how to try to integrate them into the USD pipelines. So yeah, that's also something we are actively pursuing and asking questions.
Yeah, and Vishu like hit the nail on the head there with how we work. Is we're pretty reactionary on this kind of stuff. Like there's just so much to do that we kind of wait around for Vishu to ask us for something to add to USD, and then we'll do it. So it's that kind
Yeah,
of
I mean, I could tell that Vishu, you and your company have probably put your partner companies to work there.
Yeah, it's the
That's so
same
great.
with actually Robert and Cobus as well. We ask a lot of questions with USD and Omniverse. And based on our questions, they give us feedback and make some improvements as well, I suppose. So in that sense, it's been pretty, it's very useful collaborating with all of these guys to kind of push our own platform and learn from them, which is kind of inspiring.
Yeah, and I saw that you're very engaged with the community on your forums, which is fantastic. So that's probably the number one place people should go if they want help, right? Go right to the forums.
Mm-hmm.
Yeah. We have a good question here from Energy Eagles. This is for Vishu. What do you like most about working with Omniverse? You touched on a few really interesting things. I always really enjoy the collaboration aspect when people are leveraging Omniverse and OpenUSD for collaboration, because I feel like that's just such a new thing in this manner, and I don't think a lot of people are really fully leveraging that yet. But what is it that's the most compelling to you?
The most compelling thing, exactly the connectors and the collaborative working, which is enabling people to start doing things at a very early stage. So things like visualization, you don't have to wait for geometries anymore. So you can start off very early on. So the more important thing is that you need to set up this file type, like how the various platforms and these kind of file structure has to be set up. So then once the file structure is set up, people can be continuously updating geometry in their own preferred platform and just pushing an update. And the visualizer, if they're working on Unreal or even within Omniverse, they just have to sync it up, and the work they did would be added on top of it. It's like similar to Photoshop layers. So whatever work the visualizer did would sit on top of the things, the base geometry created by the designers. So it has enabled a lot of people to work in parallel, various scopes to work in parallel, which is kind of what I think Omniverse was set out to do. And then the second aspect is the aspect of USD and how it can capture multiple data types and custom attributes and custom data, which is where we were anyway heading towards in terms of our own platform. And then OpenUSD just made more sense to use that and add our kind of, we wanted the geometries to showcase that how they are created, have a history of how it's created, how it's going to be manufactured, what is the G code for the manufacturing, all of that to be embedded. And the USD file format makes a lot of sense for that regard. So those were the kind of the two. And then third one probably would be because we, like a lot of the tool sets we kind of developed were kind of mesh based or discrete geometry based. And like a lot of the design work we do is done in Maya, which is again polygon modeling interface. So it made a lot of sense again there to kind of develop frameworks, and then NVIDIA and Omniverse also kind of develops on the same logic of discrete representation of geometry.
Very, very just amazing. And I have to ask this, non-technical, but this is, I'm also very fascinated by the type of work you guys are doing and the actual, the clients you work with. Do you work mostly with cities and large corporations? It seems like these are pretty big structures.
So we have clients in all scales, coming from private clients to governments, looking at stadiums to master plans to small scale pavilions, metro stations, train stations. So yeah, the office is around 500 people, and at this given moment, I think there are about 50-60 projects going on in the office, which are going into construction or in construction already, and then a lot other things in competition and concept stage. So yeah, there is like a lot of projects going on in parallel, and hence having a very robust compute framework is helpful in delivering these projects very quickly, because the turnaround is also very quick on these large scale projects.
You must have a very good project management team. It seems like a lot to juggle. So again, super. And also thank you for sharing this information with us. It's very, I find it super inspiring to see how companies like yourselves are doing the work you do. And to go into such detail, I think is so helpful for other people, other businesses who kind of are just understanding or appreciating what the value of an OpenUSD kind of platform enablement does. So very cool. And I see Mohammed just asked a second ago in the chat. He's asking for some of the links. If you scroll up on the live chat, you're going to see the links as they happen during the stream. We'll also put some in the description after the stream. You can catch a replay of this stream anytime on the NVIDIA Omniverse YouTube channel. And we have a few minutes left, so I would love to hear any more questions people got from the audience. I'm looking to see if I missed anything. I think, Steve, you've been active helping people in the chat, I can see. So very impressive multitasking there. Yeah, and again, if you're having any kind of challengers or you want have questions on performance, that's great avenue is the support forums. You're also welcome to come to the NVIDIA Omniverse Discord server if you want to ask there, and we'll post any links.
So can I ask a question on rendering? Of course, it's on rendering. So when you've got your pipeline, do you what's your preferred method of rendering? Is it through Unreal, or is it through say Composer or Presenter, or how do you output your actual final visualizations?
Yeah, currently within the office, so we again use like a lot of softwares in the office. It's not one specific one. Each team has their own way of rendering. So we have like some people render it in Unreal, some people do it in Enscape, some people do it in Twinmotion, some do it inside of Omniverse. So in the visualization aspect, that's something, because we started looking into Omniverse like only 8 to 12 months ago. So the visualization aspect is still work in progress. That's getting it's being tested. So we see if it can perform in the same way as Unreal would. But like currently, like a lot of the projects which go into Metaverse currently are being rendered in Unreal, and that's been where we are using them for. Also, the gaming industry path also, where we collaborate with the gaming industry, also looks into Unreal. But there's still ongoing things to check whether the visualization aspects inside of Omniverse create can match up to the ones in what we are used to in the other platforms.
Okay.
Very cool. I'm going to repost some links for people who joined us late. We'll post the Rhino link first. Check out the latest version of Rhino 8. Lots of great examples on that website if you click on it. And then we'll post a link for Zaha also. And then what's next? What are you guys kind of focused on next? I hear you may come to GTC, so fingers crossed that works out. It'd be great to meet you there, Vishu. But what are you guys? You're juggling obviously dozens of projects, but what's the main thing as you're heading off and the year? Kind of what's your next focus technologically?
Yeah, for us would be kind of growing the user base. So currently, like a team of 20 is using it. So we want to kind of make it a big more part of the workflows within the office for a wider team. So that's kind of in the pipeline for us. And then kind of developing also applications on the machine learning aspect, which is also one of the useful parts for NVIDIA, is like you have like a large set of libraries which are open sourced for machine learning and stable diffusion, reinforcement learning, so on and so forth. So kind of tap into that. That's kind of in the horizon as well.
I also saw that you guys are leveraging Yumi Studio for some of the training and collaboration. That is a really interesting platform. I'm going to post a link for that one also in the chat. We actually covered Yumi on an earlier live stream in relating to like a training we did. And it was just so easy to, what Yumi does is they basically have lots of virtual machines with Omniverse platform and lots of other software. You can spin something up pretty quick. You can have multiple users jump in. You can have a teacher that kind of takes control of different screens. Really, I encourage anyone who wants to look at new platform for helping teaching in real time. Yumi Studio is really fantastic. It's cool you guys are leveraging it. Very cool. So I also see a question here coming in. Thank you for the inspiring presentation. Will your custom tools be public at some point? I'm sure they're not public because they're probably for your business, but do you guys release anything?
Yeah, that's something I'll have to discuss with my directors. To see how,
I mean, you can tell a lot of work goes into that. Goes into what you showed off today. But
yeah, parts of it we actually showcase in our. We also teach at like various institutes at Bartlett, at the AA in London, and then some parts of it the students use it there. So parts of it is actually public, but not all of the tools. But some of them are. So we have a GitHub.
Yeah. Sorry, go ahead.
Yeah, it's not everything is not public yet, but that's something I'll have to discuss with the office and get back.
All right. Well, that is awesome. We're just about out of time. Oh, here's one last question from Energy Eagles. Put it on the screen. How will you be applying machine learning to your design pipeline?
Yeah, it's kind of like the current buzz thing. So one of the low-hanging fruit is actually looking at the text to image pipeline, like stable diffusion, which we are already looking into, and trying to augment that with custom ZHA data. So that's something we have already looked into and integrated into design pipelines, looking at early stages of computation or concept stages. It's very useful to tease out various ideas very quickly and then develop the tectonic and the design as per the various options. So it has become a kind of a design assist tool. But the more important one, actually, like what we are showcasing is kind of seeing if it can, because we have like a lot of data set about geometries of all the projects. We want to see if we can use machine learning to learn from these designs and then see if it can be a co-designer, similar to a co-pilot in Visual Studio. Similar, can it be a co-designer? That's something we are currently looking at as well.
Very cool. Well, thank you so much. I have to thank everybody for participating today. It's a really fun way to kind of show and tell and take everybody's great questions. Thank you for everyone for watching. Just want to make a nice little mention of the NVIDIA Jetson AI Lab. Recently had their first office hours or community meetup on yesterday, actually. I'll post a link for it if anyone's interested. But they planned to have such a great response, a lot of great engagement in the chat. You can watch it, the replay. They plan to hold another one after GTC. That's on the NVIDIA developer channel on YouTube. So it's a little different from the NVIDIA Omniverse channel, but the link's right there in the chat. Steve and Scott, I have to thank you guys very much as well, because I know you are super busy, and it was really fun and helpful to have you join the panel here. Is there anything else you want to say before you get back to the grind?
Just got to get back to the grind, man. No, I mean, we'd love feedback on our OpenUSD stuff. We've got an exporter. We continue to work on it. We obviously still need to write an importer, and we've structured that project in a way that it's open source, so that we're trying to make it so it's easy for people to build and actually contribute to. It's still, I think, a little hard because the way it's structured is it's more structured for an internal build for Rhino at the moment. But yeah, and then I think also we've made a lot of advances in Rhino 8 with regards to programmatically adjusting different file formats, and I think OpenUSD fits right in there. So
that's fantastic. Scott, do you have anything to add to that? No, he's good. No, and Vishu, cannot thank you enough for putting in the presentation. It was nonstop action. Every single slide was packed with amazing wow material. So really, thank you for putting that together and sharing your wisdom, and expertise, and your journey through OpenUSD. And to the McNeil team also, I think it's so great how you engage and take feedback and requests and really consider things that people will need for their workflows as you figure out next steps and building the software even further. But congratulations on Rhino 8. Really, really fantastic.
thank you.
Thanks for the invite and also the support from both Omniverse and Rhino. So
of course, yeah, we're very excited. I do hope I get to see you at GTC. Richard, any last comments before we sign off?
Just saying, you know, like, what an advanced user. I would love to. I'd be very honored if I ever got a forum request from you or any of you on. I'd love to see what level of help you would need. I'm not sure I could. I'd have to find the best of the best to help you, but that's fine.
Yeah, we have like a lot of questions. I'm happy to jump on a call.
Well, yeah, I live for questions, so load me up. You know,
it's true.
Yeah, I can connect through Robert then and get you. We can schedule a meeting, and we have a lot of questions for you.
Great,
awesome, and that's actually a great selling point for GTC, because you can actually come and meet people. Anyone out there who's watching, that you can come meet with some of the experts, some of our partners, and also each other. I can't tell you how many times I've seen really cool projects actually just start and be born by two people from the community kind of talking to each other about something they're working on, and then, oh my God, this fits in perfect what I'm doing, and then lo and behold, the new business is born. We've seen that several times over. And if you are involved in a startup, definitely take a look at NVIDIA Inception. We had Leon last week where we spoke about Inception, and Inception team will be at GTC. So if you're involved in a startup, please consider coming to GTC, or definitely just check out the Inception webpage if you're not going to be there. But that's great resources available. They're all free resources for any startups out there leveraging NVIDIA technology, including a solid number of cloud credits. And that makes it worth it in and of itself. So thank you everybody for joining us. It's been really fantastic. We'll see you next week. But in the meantime, we'll be on the forums. We'll be on Discord. And again, hats off to the McNeil team and Vishu and your team. Thank everybody for putting everything together. Really fantastic.
Thank you.
Okay, take care.